Hi, welcome back. Today's video is about the topic of linear momentum. So let's go ahead and get started. So first off, we're going to talk about momentum, what momentum is, and what it means for momentum to change. And here's an example in this picture of what is going on when something's momentum is changing. There's that fighter jet and it's running into the brick wall. I would say that it is going to come to a stop. And that's an example of momentum change. So which of these two things do you think has more momentum? It's your multiple choice question. See you in a bit. Welcome back. So, linear momentum. It's a measure of how hard it is to stop or turn a moving object. In other words, how hard it is to change the object's motion. So what kind of characteristics would make it hard to stop or turn an object? Well, big objects are harder to stop or turn than little objects. Let's see what else. I guess really fast-moving objects are harder to stop or turn. You have to have a much bigger turning radius when you're driving your car fast than when you're driving it slow. Well, let's see. Well, here's the formula for momentum for a single particle. Let's see, P. Why the heck would momentum be P? I don't know. Must have run out of letters finally. And oh, it's bold too. I guess that means that momentum is a vector. Yuck, vectors. It's a vector. And momentum, symbol P, or more appropriately, the Greek letter rho, but we'll just call it P, is equal to mass times velocity. Yes, velocity. Velocity is a vector. That's why momentum is a vector. Okay, and that's for a single particle. And the momentum for a system of particles, all that symbology says is that you find the momentum of each particle, add them all together, they're vectors, and that will give you the momentum of the system of particles. Okay, so what do you think the units are for momentum? Well, guess what? We don't have a fancy unit. So we're going to use, let's see, momentum mass is kilograms and velocity is meters per second. So this is the unit of momentum. We don't have anything fancy. Kilograms, meters per second. And then because this is a vector, after the unit you have to give a direction. Not too bad, huh? Okay, let's move on. Okay, so here's a little bit of a practice problem. Calculate the momentum of a 65 kilogram sprinter running east at 10 meters per second. Well, let's give this one a shot. Okay, so we have our sprinter running off to the east at 10 meters per second. Bump, bump, bump. Every second it's going 10 meters. Okay, well, the mass of the sprinter is 65 kilograms, and the velocity of the sprinter is 10 meters per second and east. And the momentum, P, is equal to mv. Well, that'd be 65 times 10, which is equal to 650 kilograms meters per second. Don't forget the direction. It's a vector, east. There we go. Okay, so now we have another problem. We have a 90-kilogram tackle running north at 5 meters per second and a 75-kilogram quarterback running east at 8 meters per second. What is the momentum of the system of football players? Okay, well, let's see. We have big football player. Okay, 75 kilograms. And he's got the ball and he's going to throw it. I guess that's why he's running. And he's running at 8 meters per second to the east. Now we have a even bigger football player, running this way to try to catch up to the quarterback and tackle him. And this one is a 90-kilogram football player traveling north at 5 meters per second. Well, we have two particles, and we want to know what the momentum of the system is. Well, I have to add their two momentums together, okay, to come up with the sum of the momentum. And not only that, I have to deal with it as a vector. So I have momentum this way, and that's 75 kilograms times 8 meters per second. Okay, and that's for the quarterback. And then I have momentum of the tackle. That's equal to m of the tackle times v of the tackle, which is 90 times 5, and that's in the north direction. The total momentum then is that. So let's go ahead and pull up our calculator. We'll calculate. Okay, so the momentum of the quarterback is 75 times 8. So that's 600 kilograms meters per second. Now let's go ahead and figure out for the tackle, 90 kilograms times 5 meters per second, and that's 450 kilograms meters per second. Now, to come up with the vector sum, we have to use our good friend, Mr. Pythagoras. So the magnitude of the momentum is the square root of 600 squared plus 450 squared. And the angle is equal to the inverse tan of the y component, which is 450, over the x component, which is 600. And that's equal to so the momentum of the system is equal to 750 kilograms meters per second at an angle of 37 degrees. Or, here's one. This is for the AP guys and gals. Let's put it in unit vector notation. 600 I hat plus 450 j hat kilograms meters per second. There we go. That's our momentum. So, what is this change in momentum thing? Like any change in momentum is looking at the final, initial, and subtracting. So final minus initial gives us the change in momentum. Okay? Nothing surprising there. So here's your free response question. Good luck. We'll see you next time.